917. And I even made a note on 917, I believe. Yeah. You have to go with the equation on page 191 in your book. And that example problem, I believe it was, wasn't it? There's an example problem, example 916. But you have to use the equation that the deformation equals the force times the length divided by the area times the modulus in that situation. And the reason for that, if you go back, let's see, well, if you look at the top of that solution on page 190, note it says the tensile stress is equal to the force over the area. Well, if we look at that equation, let's see, find my mouse here. Shouldn't be as hard today. If we look at that equation there, Anthony, it's the force times the length divided by the area times the, was it the modulus of elasticity? Okay, well these two right here are that tensile stress, right? Do what?
That's epsilon, isn't it?
What? This?
Yeah.
Isn't that sigma?
Sigma.
Yeah.
That's strength.
Right. And that's, again, that's that's stress. Strain is, and notice the book, in all of their stuff in the charts in the back, they simplify it. Stress is just an S, I believe is what they're doing there. Or not stress. That's not true. What? I have to go back and look what the units are on that. They're simplifying one of those. Do what?
We're talking about appendix G.
Well, it's in most of the ones that deal with any of the properties of those particular metals. Well, that's interesting.
The ultimate strength, it actually spells it out. Tense, shear.
And it might be the shear.
It just spells it out underneath the ultimate strength.
Yeah. So anyway, back to this. So that's where those two parts of that come into play. Okay. And then, so they find the stress, or is that calculate the stress. So they find the stress, then calculate the strain in each of the materials. Okay, and then that is where they take this stress, that's the equation, they go and find the strain is equal to the stress, the tensile stress, divided by what? The modulus. I'm really glad I turned that ringer off. You didn't have to hear it. Okay, which is, in the case of this one, what was it? Was this steel?
Steel.
Yeah. 30 million.
PSI.
Yeah. Well, that's this number right here, isn't it? We were given the original length. Okay. So
What number is this?
17. So when you calculate 17, what you're doing, well, I want that to move up. Okay, it's not doing it, so we'll just go with it. So the equation, as I show in the that I posted, was, let's see, do we have to do any? well, first off, we're given that the length was 25 inches, right? And were we given the stress?
15,000.
Tensile stress was 15,000 psi. And so therefore we know that what the P over A is the 15,000 pounds per 1 square inch, right? That's another way of writing that. Since this equals that equals that. So this was just another way of writing these two. Okay? So for every square inch, there's 15,000 pounds pressure on it. Right? Or force, I should say. Well, then, and we're also, are we given that the modulus is, yeah, we're not given that, but we know it based on the table, right?
Yeah, they tell you it's steel.
30 million psi. So then we just go in there. We know now. What all do we know? We got this. We've got the P, right? 15,000 pounds times the length. We know is 25 inches divided by the area. Well, we're assuming that it's 1 square inch. So we assumed right here. Okay. Times the modulus, which is 30 million. We've got enough to figure out what the deformation is, don't we? And we end up with 0.0125 inches. Or very small amount, huh?
Where did we find the table for the,
That is on
497.
yeah, 501. That's 501.
Thank you. Yep. So you might expect, you know, if it were me, if you go back and look at my machine design books and all that, they have tabs on them so that I could find where I needed to go, because I knew I was going to need to go there on a test. You know, just a thought. Unless you're planning on selling your book back, but I don't know why you'd sell those books back. I did that once. I sold my statics and strength book back. Right after I got done with it, I'm gonna sell it back. Had to buy it back before I graduated. Still have it now though. Comes in handy. I can make test questions out of it. Didn't ever expect to do that either.
What edition do you have?
It's none of these. It's not these. I'm not even sure that book's in print anymore. To tell you the truth, it was a very good book though.
So it's worth a lot of money now. It's not-
Do what?
It's not in print anymore. So it should
It's
be-
probably worth a whole lot of money now since I said I use it for test questions. His scroll. Oh man, that hurt. Oh geez, somebody pull that knife out. It's going to cause a lot more pain. What else? Does that help?
Yeah, I just wasn't sure where we got the modulus.
Yep. Yeah, and that's, I mean, no matter what material we talk about, it's going to come from that page. Pretty much guarantee that, like test type. So yeah, you'll need your book when you have the test.
Right.
So you need your book, your calculator, and I guess your notes if you want. So, what else? 19. Well, let's see. 19 says what? An aluminum rod 25 millimeters in diameter and 4 meters long is subjected to an axial tensile load of 65 kilonewtons. Calculate stress, strain, total elongation. Okay. So, what are we going to do first? Well, let's see. Probably ought to calculate the area, right? We got what I like to do is